Okay, everybody, I think we're ready to advance. Okay, so our second speaker, also from the Earth, Ocean, and Atmospheric Sciences, is Dr. Katy Sparrow, and she's going to be speaking on the future of peatlands and the planet. So take it away, Katy.
Okay, thank you. So I'm Katy, and one of my research interests is investigating how a type of wetlands called peatlands is responding to climate change. So why do peatlands matter? Well, global peatlands store 500 petagrams of carbon, which is 5 billion herds of elephants of carbon that can be released to the atmosphere by a warming climate, which would accelerate man-made climate change. So peatlands are found all over the world, from the tropics to the Arctic, and I wanted to know, are all peatlands equally vulnerable to climate change, or are some peatlands more likely to release the carbon that they store? Let's time for a song. Climate is changing, getting up. Gotta stay back, straight up. Wanna make some noise, really raise my voice. Let's talk about land. What's up, peatland? I'll help you understand. It's a carbon-rich wetland. Waterlogged soil, preserve the kind of carbon that cannot be wiped. Thinking about being a postdoc, to go through all of it to have a little fun and the totally crazy. I guess, burger, make gas, little wild gas, Next, let's check out the peatlands. What are the results? Not surprisingly, the cold and climate are more vulnerable to man-made climate change and have more to lose as temperatures rise. The best thing about being a postdoc is after all that it to have a little fun and the totally crazy. It's the right gas. Make gas, living the wild gas, and the rise for peatlands, Let's check out these peatlands. So just a few more details. I used two methods to evaluate peat samples collected at 4 different sites. Here's a map of the Northern Hemisphere, and 2 of the sites were classified as cool climates, where the other 2 are warm climates. Method 1 is called ramped oxidation, and my second method is Fourier transform infrared spectroscopy. Results from method 1 are that peat from the cool climates had greater proportions of low activation energy carbon than the peat from the warm climates. Low activation energy carbon, shown by the black bars in these graphs, is more likely to be degraded. Since the cool climate peatlands had more, they are more vulnerable to climate change. The results from method 2 are that peat from the cool climates had more carbohydrates than peat from the warm climates. Carbohydrates indicate that peat is more likely to be degraded, and because the cool climate peatlands had more carbohydrates, shown in this blue box, it means that they are more vulnerable to climate change. And finally, I found 3 unique statistically significant relationships between methods 1 and 2. And this means that these methods are highly complementary. Thank you.